Hi, thanks for joining us today for our panel discussion and series of videos at the Berkeley Big Top Tent event. And we're going to talk a little bit about the product lifecycle. As we know, all the phases of the product lifecycle are interconnected. Marty, can you tell us a little bit about how design decisions impact other lifecycle phases?
Yeah, making one decision really has a lot of ripple effects throughout a life cycle. If you think about something as simple as a shirt, deciding to make it out of cotton versus polyester completely changes both when and what impacts you would have throughout the life cycle of that product. Cotton, a lot of the impacts are going to be upfront on the producing of that cotton, things like pesticides, water use, land use. And then with polyester, it's relatively efficient to produce, but during its life cycle, during washing of it, it emits microfibers into the environment. It has a different ability to be recycled at the end of life. Even amongst the dyes and finishes that are used on these two different materials, they're completely different and therefore result in a different overall environmental impact and have a different ability to be recycled at the end of life. So even within a single garment, you have completely different impacts on the supply chain.
Yeah, and I think also when you're looking at, a lot of people are headed towards bio-based materials, which is great, but there's even decisions you have to make between bio-based materials, because depending on where it comes from, where it's being sourced from, it could have vastly different environmental impacts. So just making a decision saying, I want a bio-based material isn't enough. You need to really look at where it's coming from, and that's important as well.
So, so that sounds really complicated, and how to kind of balance all of those trade-offs, right? When you're thinking about these different materials and these different products and how to make decisions. So I think thinking about, are there examples of companies that are kind of making these decisions present day and doing this and kind of balancing those trade-offs?
Absolutely. There's companies that are switching the biorenewable feedstocks that they're using for and substituting for plastic. So one company that I know of, for example, is NewGen Surgical, and they had been supplying products to the operating rooms of hospitals for a long time. And everything in a hospital operating room, as you can imagine, is single-use, disposable, and ends up at end of life either in a landfill or incinerated. And many of them are made out of plastic and carefully wrapped, of course, for sanitary purposes, because we are in a medical facility. What NewGen Surgical decided to do is to take one example of this and see if you could substitute one of the plastics with a renewable feedstock, and in this case, an agricultural waste, so sugarcane bagasse. So they took a surgical stapler, which is usually made out of ABS plastic, and changed the bulk of that weight. 69 or 70% of the weight is switched from ABS plastic to sugarcane bagasse. So it uses a waste material as a feedstock, and also at the end of life, with incineration or landfill, it has less of an impact than the ABS plastic equivalent would have.
Yeah, and I can think of an example with 3D printing. At Autodesk, they recently developed a printer, and they use SLA printing, which is stereolithography. And this form of printing uses a photocatalyst to catalyze a chemical into a solid polymer. But unfortunately, the resin and the leftover resin that is in the polymer has some potentially toxic effects to aquatic life. So they thought about it at Autodesk through a class at Berkeley, actually, in which they collaborated with, called Greener Solutions, that Marty started. They looked into different photocatalysts, because the photocatalysts are one of the more toxic elements of the resin. Mm-hmm. And they looked at bio-based photocatalysts like curcumin, and that could be a very good option for substituting the photocatalyst, and might allow to some reduction in that aquatic toxicity with the 3D printed parts.
So where are they at the viability of that? Was it just kind of some initial research to find out if there was?
I'm not sure if I can speak to that, but yeah, I don't know yet.
Okay, great.
And there are a couple of other companies that I know Justin knows of, one, and that are also making biodegradable plastics. One is Mango Materials, which is taking methane from landfills and wastewater treatment facilities and turning them into a bio-based plastic, a biodegradable plastic. And you have another one, I think, that's similar to that.
Grow Plastics is another company. They developed a method for making PLA plastic, which is bio-based, a lot less heavy, and using air and its engineering process. And by doing so, they've been able to reduce the environmental impacts, CO2 emissions, and also make it a little more biodegradable as well.
And then what's interesting here is these are all great examples of technologies that enable products or aspects of products to be much more sustainable, whether it's adding bagasse to a plastic, adding air to a plastic. This is for a surgical device, for packaging. So there's also very large companies that are thinking about this in how do we reduce our overall footprint of chemicals. So things like the Chemical Footprint Project help help companies track their use of chemistry. Things like LCA that you are an expert in, help them figure out where within the life cycle they can make a big difference. Some of the trends that we see a lot are how do you develop materials that use less water? How do you create packaging that's not wasteful for the environment or persists for a long period of time? So I see large companies like Autodesk, but also like Nike, Levi's, Patagonia, also like Beauty Counter and Method. In each of the product sectors, you have those people who are really trying to lower the impact throughout the life cycle, and they do it by finding these kind of example technologies.
And a key part of those decisions, I think, is they're looking at multiple parts of the life cycle, and they're looking not only at human health and environment, but also greenhouse gas emissions, reducing toxicity. And I think the piece that I've been seeing more recently is combining both reducing the impacts on greenhouse gas emissions in feedstocks and processing, but also reducing the impact of toxicity in the material choices that they're making. And that's a huge shift that we've been seeing.
So you spoke about two things that I want to come back to, but first I was thinking about, so with these big industries and smaller companies driving this change, what do you think motivates them to do this? Like what kind of drives them to make these decisions?
I think it's a lot of different things. I mean, there's definitely consumer incentive that we've talked about a little bit. Consumers are becoming more aware of potential human health issues, and they're also concerned about the environmental impact. But there's regulatory as well. Recently, TSCA was updated by Congress, and there's pushes to get to more stringent regulations like REACH, and so companies are also thinking about how they can get ahead of those regulations as well.
There's a couple of other pieces. There's liability and brand reputation, that if you find there's a toxic chemical in your product and somebody else finds it, a third party finds it, that's not a particularly good thing for you. And more we're seeing investors saying that if you're part of an industry that's dependent on a chemical that's likely to be regulated, so back to what Justin was saying about regulatory drivers, that you're simply not a good investment going forward.
Yeah, recently McKenzie came out with a study that showed that companies that valued sustainability in their top 3 were companies that actually did better, economically better than other companies.
Right?
So it might be a correlation, might not be causation, but it's still a good correlation regardless.
That's a good point. And so we talked, and to your point, we're thinking about the environmental as well as some of the human health impacts. So looking at metrics such as greenhouse gas emissions, as well as toxicity, aquatic toxicity we talked a little bit about earlier. And so life cycle assessment is a tool that engineers and designers often use to characterize some of the environmental impacts. Are there other tools that are being used now to kind of address materials and product impacts throughout the life cycle besides life cycle assessment?
I think some of the complementary tools, so life cycle assessment does a great job of figuring out what the impact of chemicals emitted to the environment would be. Complementary tools take a look at what's in the product, so that if you're going to use that product, if any of the chemicals or materials come out, you do a chemical or material hazard assessment. So that hazard assessment's really good for taking a look at within the product, not with the stuff that's emitted to the environment, what's the impact going to be. So that's complementary, and that's led some of the leading tools in that area are the Safer Choice program from the EPA, Green Screen, and Cradle to Cradle product certification. All of them use a similar set of tools to look at the impact on human and environmental health of the stuff that's actually in the product.
And then you can take chemical hazard assessment and life cycle assessment and exposure assessment and risk assessment, in fact, and fold that all into a much broader frame, the alternatives assessment approach. And that has been outlined. The National Academy of Sciences put a guidebook out. It's, I think, a couple hundred pages of a framework for safer alternatives assessment. The Interstate Chemicals Clearinghouse folks, the state level folks have also put together a framework for alternatives assessment. So there are a couple that exist there. US EPA also has its own alternatives assessment framework. So all of those you can use to bring in all the different pieces of assessment that you need.
Yeah, and I think it's also nice thinking about having that complementary as what you said, right? So lifecycle does a really good job of looking at the environmental and the outputs from these products in manufacturing, but thinking about what's going into them is also important. So it's really good that also the frameworks that you said that kind of overlay these different methods that you're able to look at. Thanks for joining us today. We hope you enjoyed our videos and panel discussion. You can find out more information on the website for the Berkeley Big Top Tent event.